So here we are going to be doing an example here of a dilution question. So here's our first one. It is, what is the concentration of a 1.5 liter solution if it is made by mixing 500 milliliters of a 14.8 mole per liter solution with 1 liter of water? Okay, well, let's kind of decipher what we got going on here. So it says here that what is the concentration of a so I have 1.50 liters. Well, that's a volume, and I'll just need to figure out which one in a minute. If it is made by mixing 500 milliliters of water, well, I have 500 milliliters. Oh, sorry, 5 milliliters of this solution. Okay, so milliliters, I'm going to convert that over to 0.500 liters, and that was done by dividing by 1,000. Okay. It is made by mixing that of, okay, well, I have this, sorry, that's another volume. I have this concentration here of 14.8 moles per liter. So that's a concentration with 1 liter of water. So if I think about this, okay, what is the concentration of a 1.5 liter solution if it is made by mixing 500 milliliters of a 14.8 mole per liter solution with 1 liter of water? Okay, so the 1 liter plus the 500 milliliters is the 1.5. So I do have that right volume there. Okay, so the question is asking me though for a concentration. Okay, well, if I look kind of back up here, right, I'm going to be using this formula here, which is my dilution formula, which makes sense for the question. So I have CI/VI equals CF/VF. Now I just have to figure out in my mind, well, which one is CI, which one's CF. Okay, so if we remember back, it says that the initial volume is always going to be smaller than the final volume. Well, this must mean that this is initial and that one's final. Now, it also says that the initial concentration is going to be more than the final concentration. And the other way that I said is, like, you have to just remember, like, which one of these go together. Well, it says it is made by mixing 500 milliliters of a 14.8 mole per liter solution. So those two go together. So if this 500 milliliters is initial, then this must also be initial, and this must be asking me for the final one. Okay, so I just need to rearrange this now so I have my final concentration by itself. So I'm going to divide both sides by the the final concentration, the final volume. There we go. So I'm going to have final concentration is equal to initial concentration times the initial volume all over the final volume. Okay, well, now I just need to work that out and do my substitution. So substitution here is going to look like initial concentration 14.8 moles per liter times 0.5 liters, okay, all divided by 1.5 liters. Well, these liters are going to cancel out, and I'm going to end up with moles, right? Moles per liter. Perfect. That's what I want for a concentration. So let's plug this into our calculator here. So in order to make it so that I have all of the top divided by the bottom piece there, I need to put in some brackets. So I put brackets there, 14.8 times 0.5, close the bracket up, and we're dividing all of that by 1.5, and I get an answer of 4.93 repeating. Okay, so equals 4.93 repeating moles per liter. So now let's look up and see how many significant figures we have. Well, 3, 3, 3, 3. All of these numbers are 3. So I need to report this to 3 significant figures. So it would be 4.93 moles per liter as my answer. Thank you for watching this solution, and we'll see you at the next question. Thank you again.